Hey guys, so I'm going to try to make this video as quick as possible, but today we're going to be talking about how to classify graphs of functions as even, odd, or neither. So the question is how to determine if a function is odd, even, or neither. So if you look here, we have two conditions. The function is even when we talk about the graph. The graph is even if f of negative x, meaning you replace negative x in place of every x that you see will equal to f of x. And it's odd if f of negative x is equal to negative f of x. So if none of the conditions fit, then guess what? It's neither. So we're gonna make this quick, and we're going to I just had my pen. We're going to walk through this. I'm sorry. So we're gonna walk through this. So here, the first question that I have is f of x is equal to x squared. So what we want to do is for every x, we want to replace it with a negative x. So you have f of negative x equals negative x squared plus 3 times negative x, and that's plus 5. All right. So what happens here is negative x squared, of course, is going to give us x squared minus 3x plus 5. Alright, so from here, what we're trying to determine is if this is going to be even, odd, or even or odd function, or neither. First thing first, when we look at the degree, the highest degree is 2, so it possibly could be an even function. However, what needs to happen is if you end up with the exact same function you started off with, then the function and which means all the signs are the same, the function is even. Well, in this case, the sign change only happened for negative 3x, and x squared stayed the same. So therefore, in this function here, it's neither. All right. So we're gonna title that as we're gonna just answer that as neither. Okay. So keep in mind what needs to happen for even functions is the signs all need to be the same. So if you notice x squared was here, this is x squared, but this is positive 3x, but it's changed to negative 3x, and 5 remain positive. All signs must be the same in order for it to be an even function. So in this case, it's neither. And we'll figure out why it's not odd in a second. So here you're going to do the same thing. F of negative x is equal to 7. You want to replace negative x cubed minus negative x. Alright. So here we know that negative x cubed is going to give us negative 7x cubed plus x. So when we talk about whether it's going to be even or odd, in this case, 7x cubed became negative 7x cubed, and minus x became a positive x. So therefore, in this case, the only way that it would be an odd function is if you end up with the exact opposite of what you started off with. Alright, so the exact opposite of what you started off with. So if all of the plus signs become minus and all of the minus signs become plus. So if we look at it and we analyze it, 7x cubed was positive, but it became negative, and negative x was negative and it became positive. So therefore, this function would be odd. So now if you look at the two functions that we just talked about, all of the signs didn't change, so therefore that's why it wasn't odd, and then all of the signs did not remain the same, so therefore that's why it wasn't even, so we put neither. So this function is neither and this function is odd. Alright, so make sure you review your notes that you were given in class to kind of help you understand and be able to continuously identify when we're working with these types of functions. Alright, so moving on. So here we have determined graphically using possible symmetry whether the following functions are even, odd, or neither. When we are talking about graphically, you want to make sure that you know that even functions are symmetric with respect to the y-axis. Okay, so we know the y-axis is here. All right, and this means that if we could fold the graph along the y-axis and it will line up perfectly on both sides. Um, Also, when we're talking about odd functions are symmetric with respect to the origin. When we talk about the origin, we're looking here at the xy, which will be 0, 0. This means that we can rotate the image 180 degrees about the origin, and it will appear exactly the same. Another way that we can do this is also by checking the coordinates. So here to the side, I'll just write even. So if you pick some coordinates and you start off with a positive x, y, well, it should match negative x, y. All right. So for example, if you have 1, 1, and you find another point on the graph and it's negative 1, 1, then that graph would, that function will actually be even. As far as the odd here, you have x, y. It should match negative x, negative y, meaning if you have 1, 1, your point should be negative 1, negative 1. Alright, so those are some good facts, good facts or information, however you want to say it, to the side that will help you. So I'm going to continue on because I don't want to make this video any longer than what it is. But thank you for being patient. So here, looking at number 1, if you notice at the bottom, it tells you to write 2 coordinates. So I'm going to go ahead and find the coordinates for these 2 points that are on the graph. So that's negative 3, 3. And then this point will be 0, 4. So if you compare the information that we have, these 2 coordinates does not meet the conditions of even or odd. So we're going to say that this graph is neither. Alright, I can even look at that and say, okay, if I fold that along the y-axis, will it be perfect? Will it have a perfect symmetry, or whatever the case may be? So that's neither. But then when I look at number 2, I'm going to write 2 coordinates. So I'm going to do negative 1, 1. And then I'm going to do 1, 1. So looking at these 2 coordinates, and I look over here to the conditions that that I gave you in the beginning, and I'm going to see if it matches even or odd. So when I look at it, I'm going to assume that it matches even. But first, let's look at the graph here. If you look at that, that's a V. So if I were to fold this over, will that be folded perfectly on both sides, like it'll line up perfectly on both sides? And you should agree with me and say yes. So this function here is even. Okay, and I'm going to do one more. I'm going to do one more, and let's see which one will we do. Let's look here. Alright, so let's look at this one right here. I'm going to pick a point. I'm going to pick this point right here, which would be 1, 1. Then I'm going to pick the point here, which would be negative 1, negative 1. And once again, I'm going to follow my conditions. So I'll give you a second to kind of look at that. So in your mind, if you said that this was an odd function, then you are correct. The function is odd. And also, look at how it goes through the origin. And remember, when we're talking about odd functions, this means we can rotate the image about the origin. It will remain exactly the same. Also, remembering from our parent functions, this function will be f of x is equal to x cubed. Notice the degree of this function here is 3, which is an odd number. So we can assume that functions are odd functions based off of degree, but sometimes you got to make sure that you work it out and look at the actual graph. So that's all I have for you today. If you have any questions, please feel free to comment in the comment box below. Also, subscribe to this page, and I hope you guys have a good day. Bye.